Hello, Hemant, Mohammed, Sandeep.
Hi Mahesh.
Hi guys. Hi. I had a client call, guys. I was messed up with that call, so I'm sorry for making you wait for a while. Everyone, can you hear me properly?
Yep.
Okay, Mohammed, are you there? Sandeep, Sonia. Okay, okay. I really apologize, guys, for making you wait for a long while. Okay. Can you all see my screen? Everyone?
Yeah.
Okay. Last time yeah, thanks, Sandeep. Yeah, last time we discussed about the ecosystem of Hadoop. We need to go much more in detail, and regarding the credentials which I was talking about, the server interface, guys, we didn't got any confirmation from the organizer, so I didn't created those. Probably, yes, Mohammed. Okay. Probably I might give you those credentials on tomorrow, because since this afternoon I didn't got any update as such regarding the the number of count and all. So I had to wait for those confirmation from the organizer. So yeah, I see that all four of you are there on the bridge for sure on tomorrow. You'll get the details, or the credentials of the server which I was talking about by tomorrow, and you can access your server from there onwards. Okay, and I'll walk you through the installation process on that server itself, guys. It's completely based out of Linux, and I'll see that you are given a walkthrough on an installation process on Linux itself. Okay, now hopefully all of you see my screen. Today we'll discuss about the architecture layers and along the ecosystem of Hadoop, which will explain us in detail more about what is that you need to do after structurized data types, and if it is like unstructured, or if it is in multi layers in the formation, what all you need to do, and when you read, what is that speed or the schema that you want to look after. So this table talks about the RDBMS process and the Hadoop interface, which is a solution for the failures that has been faced in RDBMS concepts. In RDBMS, if you look at the table, there are like limited and no data processing, and the data type is completely used by the processing procedure. But in terms of Hadoop, it is coupled with both data and processing structure. And likewise, there are like various solutions given in terms of Hadoop interface. Now, whenever you are supposed to write any Hadoop interface process along with a schema, in RDBMS, you need to create your own schema on your own self. But when it comes to Hadoop, you don't have to look after any schema interfaces. You need to require or read the existing schema which is available. In terms of licensing, yeah, you need much more cost effectiveness in terms of RDBMS. But in Hadoop, you just need only support for licensing. That there isn't any need for you to buy and invest more huge costs in there, because it is completely a freeware content. In terms of the resource allocation, always a growing complexity or the wide issues that are coming up in terms of resource allocation. You will have an entity allocated. That's where the ecosystem walks you through. These are called as processing unstructured data with massive storage, the last column which is talking about. And then this next slide will give you a complete example where exactly these all fits in into a specific core structure. Guys, this is a difference between Hadoop 1.0 and 2.0. Everyone, you are able to hear me, right? Hemant, Sandeep, Sonia, Mohammed?
Yeah, I can hear.
Yeah. Okay. Now, today I just want you to walk you through what exactly the Hadoop ecosystem is, and where are we going on to start working with the Hadoop ecosystem. Now, talking more in detail, yeah, thanks, Mohammed. More in detail about the ecosystem. We have independent values, like independent ecosystem values, wherein in 1.0, if you keenly observe, we have three major components here, like the Hive, the Pig Latin data analysis system, and Mahout. These are like various aspects which is completely included in the workflow process. And even today, or earlier, it was like Apache Uzi, which is handling the entire workflow. When talking about the data warehousing system or the data analysis or the machine learning process, till now, Hive, Pig are like playing a biggest role. When Hadoop 2.0 has been introduced, if you see on the right hand side, you have something called as Yarn introduced in the framework. which is, as you know, it's at another resource negotiator, and this fellow will talk to independent nodes. So guys, in Linux environment, if you start working on Hadoop in Linux environment, what it does is it will take your interface level, it will start clustering your node, and it use something called as a distributed layer architecture, wherein the MapReduce framework will be reduced to a greater extent, and Yarn will take control on your MapReduce. In Hadoop 1.0, there is something called as HBase, which is driving the entire MapReduce framework. But when it comes to 2.0, MapReduce has been optimized to a greater extent, and more room space is given to the clustering process in resource management for Yarn. Because Pig and Hive and Latin, you know, these Pig, Latin or Hive, these two are completely into data warehousing systems. There are not any solutions provided. But when it comes to Yarn, Yarn completely accepts multi-cluster resource management. Guys, please remember, when you start working on Hadoop, it's not always only on a single node or a single cluster. It should be always on multiple nodes with multiple clusters. Going on, if you want to handle any files or the HDFS file system in Hadoop, you need to know some programming on Flume or Scoop. Using Scoop is something based out of a SQL content, and Flume is something a semi-unstructured data format wherein you use some programming there. Because HDFS or MapReduce framework needs some Java core ethic. That's what I'm saying. In this course, I'll be training you completely on Java basics, wherein you'll be given a walkthrough on HDFS file system and MapReduce at a high level. And then we will go in a chronological order, guys. See, we'll start analyzing how Flume and Scoop works on for structured and unstructured data. Maybe it can be in any format. It can be from any social networking process, or it can be from a relational database. It can be from any resource file like Excel sheets or something. You send this entire bunch into the HDFS file system, Hadoop file system, wherein it starts processing the data, analyzes which is structured and which is not structured or which is semi-structured, and from there it will take it back to your Yarn cluster. Now that's what I'm going to do on tomorrow for you. I am going to give you access for each and every independent machine, wherein you will be logging into a single cluster and request will be sent across to multiple nodes. Now, last session I told you I'm going to help you out working on setting up Hadoop for multiple nodes. Now, how is that possible? From your local machine, the moment when you start accessing my remote Linux machine using your credentials, what it does is it will accept your request as a single node. Likewise, several requests comes from several people who are authorized as an independent users. All those will be considered as multiple nodes, wherein you will be hanging inside a Linux machine, sending requests and getting response through your cluster resource manager called Yarn, wherein you will have an entire setup working on. Now, this is how we are trying to setting up a real-time interface, guys. Talking about this, you need to write some programming core. Now, what is this inside? What is this programming called? We will write something called as a mapper functions in MapReduce, a framework content, wherein you will have the entire logic or the interface written. And in that, you need to handle maybe your SQL, or it's called as NoSQL in Hadoop. And for your information, you don't have to be an expert in writing or designing your database tables or any DML commands or DDML commands or blah blah. What you need to do is you need to be able to access the database content and see whenever a resource or a cluster sent across through a node, how is that Hadoop responding to your workflow. That is the main content that you need to look after, guys. Because do I have to send my request which is from Yarn through Hive or Pig or Mahout, or is it through Yarn framework itself? We have to make a decision factor over there. Now, everywhere it will not be the same, guys. The workflow which you are looking on the screen for every client. For example, I am working for a healthcare client right now and a banking client. For my banking client, there will be like hundreds and loads of data. Like it will be in zettabytes coming on for me on a daily routine. But when it comes to healthcare, it is not that way. Sometimes it is only gigabytes only. Sometimes it crosses zettabytes. It's likewise basing upon the business strategy. So you need to decide on the workflow. Do I have to send every request through Yarn framework, or do I have to stand with Hive by sending a Flume request directly through my Yarn cluster? The workflow depends on this at a high level. So guys, I'm going to give you a walkthrough both on 1.0 and 2.0. Besides, I'm going to give you a walkthrough on a framework content called MapReduce framework. which will be a part of YARN framework also. So these are the main frameworks which we're gonna cover in the ecosystem at a high level. Am I clear so far, everyone? Any questions, everybody? Yeah, yes, buddy.
Yarn is a resource management system where it handles the requests that are coming into the system, is it?
Yes, not just the request, buddy. It will just handle the responses also, wherein you send a request back to the cluster and send it or receive it both ways again, because the workflow completely depends or demands. Okay, somebody has a question. Okay. Okay. Just give me a minute, guys. Okay. Sure, Sonia, I'll do that. Nobody today, actually, guys. I'm sorry for that. Organizers are getting some messages regarding the delay. I really apologize for that, guys, because I had a client call and it was not it was not standing up to the fixed time. Got extended 20 minutes more, so that's the reason I'm late today. I'll surely inform you guys before, or else I will not make you wait for a longer while if there is any delay or something. Okay, sure, I'll do that, Sonia. Thank you. Okay. Yes, Hemant.
So if the HDFS system is deciding in your system, and I'm a client, I'm requesting some data from the HDFS system. So YARN will be deciding over the HDFS system, right? On your system.
Yes, on the cluster which I'm talking about, you will have a complete HDFS system wherein the structured data or unstructured data will be received from your end, guys. For example, we have 4 people here: Mahesh, Mohammed, Sandeep, and Hemant. All 4 of us will be hitting up a Linux machine, wherein the data content will be sent from our machines to that remote machine.
Right.
And this remote machine content will be sent either through Flume or through Scoop, any one. Not both, guys. Please remember, we cannot use both at a time, guys. Everybody, you either go with Scoop or you either go with Flume. Okay, please remember, never ever say that you worked on both at a time. No, once you send the data content back again through your file system, there a filtering will be done through your cluster manager, maybe YARN, maybe MapReduce, because we are gonna use Hadoop 2.0. Hadoop 2.0 completely supports YARN. That's the new enhancement in 2.0. If it is with 1.0, you don't have to worry about YARN at all. MapReduce has an inbuilt framework default in Hadoop 1.0. It handles through something called as HBase. And from there, guys, it is not done. From there, you need to send it across for data warehousing process or analysis process, anything which is easily for the machine to learn on in terms of structured or unstructured data. As I said, guys, see, I have like 10,000 records, as if right now. To retrieve those records, how much time or how much tentative time I need from one cluster to another cluster, so that if my client sends a request, I need to get the response back within no time. Who is going to do that optimization for me? Who is going to analyze the data content for me and see what is the scaling to be done for getting the data back? Here comes Hive and Pig. These are the components which are mostly used, and Oozie on top of everyone is like a complete structurized way of analyzing your data. Basing upon the handling process done by Hive and Pig, Oozie starts working on your entire workflow. Now, who decides on the workflow? Your client. His work ethic, his business strategy, the load of data that he's going to take on a daily routine. This is what will be at a high level. Guys, the slide which you're looking at is not just a normal slide which you're looking at. That's the real work strategy which we are going to implement on a real-time basis. Everyone, are we clear so far, everybody? Mohammed, Sandeep, Hemant?
Yes.
Okay. Can I go ahead? Any questions so far?
No questions.
Okay. Now talking about further components, whenever there is a request coming on from our workflow, who will be the point of contact? Now, for example, we 4 are in a group right now. I want to send a request from Mohammed. As you said earlier, we have something called as a word count example. Now, what does the word count example does? How many specific words are available in my cluster? and how many times I have to count it, and what is that the counting strategy goes on. So that's like independently validating your table content. Guys, in a normal database, you will have your table values and rows and columns inside it. When it comes to Hadoop, it's not that way. There is a structurized way to handle your data. It will independently analyze, and it will independently allocate indexes for your data content, so that you can receive the data back again and read it from a remote location also. So the technique that is applied in Hadoop 2.0 or 1, the reading capability or the retrieving capability will be multiplied into 100 times. It will be faster than the normal RDBMS concept. And again comes YARN here. YARN is the clustering process which will help you to do that and receive the process content, so that your data content is readily available from a remote location and stored at a remote location, easily accessible, faster accessible, and shared across multiple nodes within no time. That's the beauty of Hadoop. That's what we're going to learn. Okay, everyone.
Okay.
So, Mohammed, guys, have you tried installing Hadoop on your machine? I heard your Cloudera, which you used earlier.
I have CDH 5.7 on my VirtualBox.
Okay.
And I believe that's for Red Hat, already installed on there.
Okay. So you have started enabling the cluster on that Red Hat Linux.
It just has the whatever CDH. I think CDH 5.7 has all the systems in there: the Hive, Pig, Yarn, HDFS, and I believe Uzi as well too.
Yeah. For the time being, Mohammed, can I make you as presenter so that we can walk them through?
Yeah, sure. Let me start up VirtualBox.
Yeah. Hang on. Let me ask these guys. Okay, I am the presenter. Hang on. Because guys, I haven't enabled your credentials yet, so the workflow which I'm showing you is it should be live, guys. Not just a slider here. Guys, I'm asking Mohammed, 1 minute. I'm asking them to make you as presenter.